another. Why I'm going to study this is because FTIR is very important in a basic drug research. FTIR is a very important tool for the basic drug research and structural elucidation, formulation development and validation technology. And third one is the most important aspect, that is a quality control process for incoming and outgoing material. If you see simple theory, I'm not going to most of the people, you can see what is the minimum requirement of any one compound which can shows IR active, that is a dipole moment. If you see these two structure of the carbon dioxide, one is a symmetrical structure, another one is asymmetrical structure. Only this asymmetrical structure that is the IR active, because the dipole moment is not equal to 0, whereas the symmetrical structure is the IR inactive, because dipole moment is 0. So this, my dear all the participants and my dear colleagues, one should understand the dipole moment is a play important role in a IR activity. If the IR active substance is there, there must be in a change in a dipole moment. And everybody knows this. Usually when anyone should understand the FTIR, he should know the two things. One is the stretching, another one is the bending. What is the major difference between stretching and bending? In a stretching, we can the change in a bond length, okay, whereas bending is a change in a bond angle. Once again, stretch can be divided into symmetric and asymmetric. The bend can divided into the in plane and out of the plane. Most of the people you can observe when you Google it, or you can get any from the book. What is the important understand to theory is the compound should have in a change in a dipole moment when you, then second one, it should stretch and the bend. Okay, what is the exactly when you see the stretch and bend? If you can you see the what I am holding this one? If everyone anybody can you see? Can you see the what I am holding? Anyone, can you explain? Anyone, can you tell me? Can you tell me, anyone? Just can you? What is this? Spring.
Spring.
Okay, very good, sir. Just to understand, if I pull, this is called stretch, and this is called the stretch. To understand any one molecule, if I take simple water, also it is like a spring, like a structure of the oxygen towards the hydrogen, oxygen towards the another hydrogen. And so if you make any one stretch either this way or this way, there is a change in a dipole moment. If there is a change in a dipole moment, then only any one compound we can say it can absorb the IR radiation. What happens when in any object, when it is absorb the IR radiation, either it's stretch this way or this way, or it bend. Can you see? It is a very simple way to understand. If you, this is the stretch, either this way or this way. If you stretch this way or if you stretch this way, okay, this is called stretching, and this is called the bending. The stretching required more energy than bending. Okay, if you see this one theory, then you can understand why this stretching and bending is very important in a IR spectroscopy. Stretching, all the vibration we can observe in a 3600 to the 1500 reciprocal centimeter, and these are very important, assignable, and you can very easily differentiate from one functional group to another functional group. Let us once again see how this infrared spectrum, when you see, it is divided into three parts. One is a near IR, which can start in a 14,000 to 4,000 reciprocal centimeter. The second one is in a mid IR. It can start around 4,000 to 400 reciprocal centimeter. Third one is in a far IR. It can start in a 400 to 10 reciprocal centimeter. But today's interest is in a mid IR. That is we are discussing about 4,000 to 400 reciprocal centimeter. And another reason when I told the stretching is very important in a 3600 to 1500, in another reason we can call it in a fingerprint region that is a usually contains a large number of unassigned vibrations. I'll just repeat. The area which contain large number of unassigned vibration, roughly between 1400 to 700 reciprocal centimeter. This region usually we can call the fingerprint region. In a fingerprint region, usually it is complex. Sometimes it is difficult to interpret. But if you are taken the in a IR spectrum at the standard condition, like in a very important nitrogen condition or argon condition, so that time it can very easily identify. But in a most of the time in a regular practice, it's difficult to take in a such standard condition. So in a fingerprint region is a complex, and more or less it is the more large number of unassigned vibrations. Let us come to another what we are going to observe from the when I look from the IR spectrum. Usually the three type peaks I'm going to get. One is a strong peak. Usually it can be denoted by the S, the medium peak M, and weak peak it is a W. Okay, whereas exactly in a opposite when we are discussing about NMR, nuclear magnetic resonance, there S means singlet, M means multiplet. Okay, so but as of now in an infrared in a spectrum, in a strong S means strong, medium means M, weak means. Apart from this, we are having the one more peak that is a very important one is broad peak. It is usually in a opposite like in a Gaussian peak, and this play important role of alcohol, carboxylic acid, and carboxylic acid derivative. And most of the important to understand whether my compound is containing moisture or my compound is completely dry. So this in a broad peak can help you to understand what is the nature and what is the condition of my compound. Let us start to understand what is the alkane simple. Okay, if you take the alkane, I want to know there is a two important things, symmetric and asymmetric structure of CH structure of in a CS3 and CH structure of in a CH2. And whereas in another way, asymmetric and symmetric CH structure of in a asymmetric and symmetric along with in a methyl CH structure in a CH2 and CH structure of the CH2 in a bending. If you take simple one example as a in a dodecane is a very clearly indicated that there are three types of peak we are going to observe at 2993 to the 2817, and these peaks basically in a symmetric stretch and asymmetric stretch. Whereas another important peak at somewhere between 1461, it is the in-plane bending, and there is this spectra is taken in identical in a standard that is out of in-plane in a rocking. So to understand a simple alkanes, one should know where the CH structure of CS3 and CH in a bend of CS3 and CH structure of in a bending and CH of the CH2 the bending. But these are more or less one important. It comes somewhere between the 2992 2800. That is a 2800. These peaks we are going to observe. But if you take apart from this, we can have. Voice is not clear. Yeah. So now can we able?
But some other voice is coming. I think your mic is touching to some. So it's again second sound is coming from it.
Okay. I'll hold the mic in the mouth. Okay, sir. Now can you see? Okay. Can you now?
Yes. Now it is okay.
Okay. Yes, so, for example, if you take simple octane, if you take the octane, I can observe in a CH stretch of CS3, okay, and CH the stretch of CH2. It is a very important in a 2990 to 2800, and these peaks are very strong peak. Okay, and another important peak of bending peak, where I am observing somewhere the 1472 1390. The please, my dear colleagues and student, these point you note it down. Next time, next slide, these 2 points are important. How I am going to differentiate between these plain alkanes and branched alkanes. Look at this. Most of the people, no one is working in a simple alkanes, I know, but to start to understand better in a IR, I have to start with first alkanes. Then it is a very easy to understand other. I do agree most of the people, no one is working hydrocarbons in a present day because of most of the well equipped in a spectroscopy available to understand these structures. But if you see the branched structure, still I am getting the same peak at in a 2900, 29992, the 2800. But when I see this is the broad peak. Can you observe? If you see the previous one, these are the sharp peak, and these sharp peak we are going to observe at the plain alkane. Okay, but if you see these broad peak, we are going to get in a branched. So this is the one of the best example. Those who are sitting in a gate and those who are sitting in a competitive exam, most of the time they will ask how you are going to differentiate branched alkanes and in a plain alkanes with the IR spectroscopy. And along with the CH2 and CH3, we are more or less we are observed at 1390 to 1360 the reciprocal the centimeter. But if when you compare to in a plane, these branched, they are a little bit weak in their weak concentration. Let us now see in a cyclic compound. What is the difference between, now you are understand the difference between plain and branch. Now we are going to understand how in a cyclic alkane it looks like. In a cyclic alkane, the very important, there is a missing of CH stretch of CS3. The missing of the CH stretch of CS3, I am going to observe at CH stretch of CH2 somewhere in a 1992, the 172780 reciprocal centimeter. The most of the time you may ask the question to me or yourself, sir is telling most of the time CH stretch of CS3 and CH stretch of CH2, they are in the same region. It is actually they are in a little bit difference, but most of the time they are having the overlap. Because of overlap, these CH stretch of CH2 and CH stretch of CS3, we are going to observe somewhere between 1990, 2992, the 2780 reciprocal centimeter. But can you observe, there is no CS3 absorbance peak somewhere around 1375. So this is clear cut. We can differentiate from the cyclohexane to hexane. Is another very important to understand those who are sitting in a competitive exam, how you are going to differentiate cyclohexane and hexane to in a IR spectroscopy. Can you see there is no peak of in a CH stretch of CS3, sorry, CH bending of CS3 absorbance peak at 1375. Okay, here I am giving in a comparison. If you see the comparison, one should know okay, can you see here? You can see the CH3 absorption somewhere around 1375 reciprocal centimeter, and that peak they are missing over here. And very the cleanly we can observe when I'm taking the simple in a hexane, the peaks what I am going to get and whatever I'm going to get in the same region. But here the both CH touch up CS3 and CH touch up CH2 I am observed, but here only I am going to get in a CH touch up CH2. And this is the one of the very important observation what we can make in a simple alkanes to understand in a branched, simple, and cyclic alkanes. Let us see in some time now onwards in a alkene. Alkene are in a simple olefinic. When you see in a alkene, before going to understand what is the minimum requirement to understand before going to the alkene. Here, instead of CH touch of CH2 and CH touch of CH3, it may be available. Apart from that, it is a one very important CH touch vibration we are going to get in a somewhere between in a above 3000 in a reciprocal centimeter. This is another important point. Whereas alkanes and branched alkanes, I'm going to get the CH stretch of below 3000. Here I'm going to get somewhere in a 3095 reciprocal centimeter to 3010 reciprocal centimeter. This is the major the difference between when you say in a alkene and alkane. Apart from that, if you take alkane, it is very difficult to assign carbon-carbon single bond in a stretching, but it is the characteristic stretch of the inner alkene that we are going to observe at somewhere between the 1680 to 1600 reciprocal centimeter. Now, what is the addition I'm going to do here? Here I'm going to do addition is C double bond C stretch is important, and CH stretch we are going to observe as a more than 3000 reciprocal centimeter. Okay, so if you see this in a conjugated and non-conjugated system, and apart from that in a benzene system, what makes us to understand in a better way is if you take the carbon-carbon single bond, it is the bond length is 1.53 angstrom, whereas carbon-carbon double bond is 1.34 angstrom, whereas the benzene has got 1.38 to 39. It is in between. The benzene, whatever the carbon-carbon in a length, it is neither behaves as a double bond, nor it behaves the single bond. Some of the book and some of the, if you go to the in benzene or aromaticity or aromatic character, we can call this as a bond order 1.5 bond order. You can say 1.5 the bond order. So that's what, if you say the isolated, conjugated, and aromatic, we can observe the 1680 to 1600 reciprocal centimeter. And another important point here to understand in a aromatic compound, here also we are going to get in a CH stretch of aromatic, it is a 3100 to 3000 reciprocal the centimeter, and it can sometime, if you are having the aromatic character and as well as alkene character, and these CH stretch of aromatic and the CH stretch up of doubly bonded character, there may be chances of overlapping. Look at this. This is the one simple spectrum I'm showing you here, how the CH stretch I'm going to observe at 3080, the very strong peak. And the CH stretch also I'm going to get in a peak. And another assignable peak at 1642, there is a carbon-carbon double bond stretch. And apart from that, CH bending. Already I told the CH bending, you use the very important when you are having the cyclic and acyclic structure. But in alkenes, if I want to take home message, what is the important one here? The CH stretch, we can observe at 3100 to 3000 reciprocal centimeter. And another one is carbon-carbon double bond character. I'm going to observe somewhere between in a 1640 reciprocal centimeter. Look at this. What is the difference between when I take in a cis trans system or in this one? This also can play very important role. Can you see the carbon-carbon single? It can give the in a cis system, or we can say we are not going to assign any cis and trans. Here, the very strong peak we are going to observe. Whereas if you consider in exactly the cis system, there is a carbon-carbon, the whatever the stretch, it can weak structure as compared to in a previously in a strong character. Look at this. If now in this in a slide, I am going to show you all three. One is simple hexane, and that is alkane, alkene, and the branched when you want to say in a cis and trans system. If I want to look at in a system, whereas in alkane, there is no absorbance or there is no band at 3000 to 3100. Same things in alkene, I am going to observe 3000 to 3100. And same things I am going to observe in a alkene. What is the major difference between alkane and alkene? In alkene, I am not going to get the CH stretch peak at more than 3000, but whereas in an alkene, I am going to get more than 3000. Whereas alkane, CH stretch, I am going to get in a below 3000, and whereas in an alkene, I am going to get above 3000. And what is the major difference between the carbon-carbon single bond? It is not assignable. It is not assignable, and sometimes it goes to in a what I can do, overlap the situation. But in a carbon-carbon double bond, it's a very easily identify or the in a alkene. Okay, so this is the major difference between when you take the alkene, and if you go take the cis and trans system. Let us come to now alkyne. What is the one more addition? If I want to have a alkyne along with the CH stretch of CS3, CH bending of CS3, then symmetric and asymmetric, then I am having the one more here important point is the CH stretch of triple bond character and C triple bond C character. So sometimes most of the people, they are confused over the nitrile and alkynes. Most of the time they are the students, they are confused over the nitriles and these carbon-carbon triple bond. And most of the pharmaceutical chemistry or in a organic chemistry, nitriles are more common, but alkynes are the less common in their reactivity. Okay, now if I say in alkynes, the very characterable or assignable peak I'm going to observe somewhere between in a 3300 to 3200, the strong peak, and along with somewhere around in a 2200 to 2100, or sometime in a 2200 or 2290 to 2100, there is a strong peak of carbon-carbon triple bond we are going to observe. And this is the another major difference between the alkane, alkynes and alkenes and alkynes. Look at this. What peak I am not going to observe from here? If you see this structure, the carbon-carbon triple bond we are going to get, and carbon triple bond character CH stretch we are going to observe. But if I take in a substituted, or I can say long chain of the in an alkyne, where I'm not going to observe any carbon-carbon triple bond character, it is a very less. Okay, whereas if you take in a normal condition, if I am having the terminal alkyne system, that time I'm going to observe in a very important C triple bond character. If any C triple bond character, it comes in between more or less, we are not going to observe any carbon-carbon, the triple bond character. Here also, we are missing about CH stretch because there is no CH stretch of the character. This is the major difference between, once again, when we are discussing with in a competitive exam or net set, and even in a gate exam also, these questions, the very clearly they are going to ask how you are going to differentiate the oct 1 in and oct 4 in. These are the most common questions when they can ask in your competitive exam. Look at this. Why? Now answer is why they are not. In a terminal alkyne, there is a change in a dipole moment, whereas in between our internal alkyne system, the dipole moment is nearer to 0, or you can say very small or nearer to 0. That's what we are not going to observe at the internal alkyne in a stretching of the inner IR spectrum. Let us to understand just now what I discussed about the S character, that is a SP, SP2, and the SP3. If I summarize, SP3 hybridized is a 1/4. That is a is it okay? Can I audible?
Yes, sir. Yes, sir. You may proceed.
Okay. Okay. So if you take this character, 1/3 character and 1/2 character, you can understand where the CH stretch. If you say sp3 hybridized, it is the 2800 to 3000 reciprocal centimeter. And if I take sp2 hybridized, 3100 to 3000 reciprocal centimeter, then come to sp hybridized, it is somewhere between 3300 reciprocal centimeter, and that is a very sharp peak. Okay, I think this is the very important what we understand in a previously. Let us go next. The most common functional groups which is present in the pharmaceutical chemistry are in a more or less in organic chemistry. That is alcohol, primary, secondary, and tertiary amines. Even alcohol also primary, secondary, and tertiary alcohols. So these alcohols and amine can play very important role in a IR spectroscopy, because more or less they appears in a same area but in a different conditions. Whereas alcohol and amine, in a other sense also in organic chemistry, it is a very important. One should understand whether they are the bonded or non-bonded. What it means, whether they are internal and external, the hydrogen bonded, they are non-hydrogen bonded. Usually we can call alcohol, there is a free OH or bonded OH. My dear, it's a very easy to understand these amines and alcohol, but I am telling you, very carefully understand whenever you are performing any reaction, whether your final compound or whether the starting compound, you are having any internal and external hydrogen bond, and how it is going to change when you are going to get the final product. Okay, look at this. If you take this is the one simple butanol. If I take the butanol, if I make in a bonded and the free means I have to take this in a carbon tetrachloride or in a very in a dilute compounds, or the sometime in a chloroform also, but it can give the better result in a carbon tetrachloride. You can see dotted line, the dotted sharp peak at somewhere it is a 3600. So this can differentiate between the bonded and non-bonded. If it is a free, along with the broad peak, I'm repeating once again, along with the broad peak, we are going to get one sharp peak in a alcohol. So these indicates that my compound do not have any hydrogen bond. If I'm having the only without any sharp peak, only broad peak, then I can say my whatever the alcohol or primary alcohol, it is bonded with a hydrogen bond, either in an internal or in external. Most of the time, it is an intramolecular hydrogen bond. And one more important things, what I'm going to observe, additional peaks or additional understanding over the CH touch up CH3 and CH bend up CH3, CH touch up CH2, and CH bend up CH2. Here, there is a very important understanding, OH stretch, that is a hydroxy compound. Okay, the OH stretch usually one can observe somewhere between in a 3552 or 3600 to 3200, the broad peak. Okay, these broad peak always it will give the problematic when your compound having the moisture, or in a like a Belgium condition, or even in a some of the in a cold condition, in a most of the August to September, October, November, up to November, if you take in a IR, more or less you are going to get the peak somewhere between 3600 to 3200. It is because of moisture is present in your compound. For that, you have to make the very important in a dehumidification, and your compound before going to put in an IR machine, it should be dried along with your mixture like a potassium bromide. Look at this. The second one, what I had told you, in a benzyl alcohol. In a benzyl alcohol, I am not going to get any sharp peak, which indicates there is a whatever the benzyl alcohol, the OH, it can make the intramolecular hydrogen bond. And if you see along with that, I'm going to get these peak. If you observe these peak, it can help you to understand whether my compounds having the monosubstituted aromatic or in a disubstituted aromatic, and even sometime it can give the clear-cut indications of substitutions. Look at this. Apart from this in a benzyl alcohol, very important peak of the CH2. The CH2 peaks also I am going to observe here, and the CH stretch B, the CH stretch of aromatic also I am going to observe. This is one of the best spectra for the anybody want to understand to differentiate OH, CH2, and CH. If I repeat once again, so these if I say this considered is a very important. This is the OH stretch, and this is the CH stretch of CH2. Sorry, CH stretch of aromatic, and the CH stretch of the CH2. All three I'm going to observe. Most of the time, if you are having any one alcohol, it is very difficult to observe all three, because more or less these peaks, they are overlap in a normal condition. That's what the one should take in a IR spectrum in a standard condition. Okay, look at this. If you take simple phenol, I'm going to get little broader in sense. If you take the organic chemistry history, these phenols, they act as acidic in nature. They act as an acidic in nature. According to some of the literature, studies says that, okay, acids more or less, they give the very broad peak because of the acidic OH. Here also we are going to observe somewhere in the broad peak, somewhere in a 3600 to in a 3000 reciprocal centimeter. And another important peak I'm going to observe in above 3000 reciprocal centimeter. If you see the above 3000 reciprocal centimeter, there is a CH stretch of in a aromatic. So this stretch is a very easily we can observe. And another one is carbon-carbon double bond. So these here we can observe in a usually 3 to 4, somewhere between the 1400 to 1620 the reciprocal centimeter. And this is the assignable peak. If I take in a fingerprint region somewhere around 1400 to this, so these are most of them some unassigned, or you can say if you take in a standard condition, we are going to get in a different bending and the different stretching. So these things only we can understand once I perfect with the stretching the characters. Next, if I take this one, amines. So these amine can play more important role over these bonding and the non-bonding character. Here also we are getting the same peak, but not a broad peak as we are observed in a alcohol. Here also we are going to get sometimes some people they can act called as a shoulder peak. Sometimes they can called as a two-peak system. And usually one should understand, apart from CH touch of CS3, CH touch of CH2, CH touch of aromatic, here one should understand there is a two-weak peak I'm going to get. One is the symmetric, another one is the asymmetric in a NH stretch. And along with, I'm going to get in a NH deformation or in the bending. So this bending, I'm going to tell you, it can give the very confusion state when you are going to get in a amide state. I'll tell you when amide comes. Yeah, just you remember the amide NH deformation. I'm going to observe somewhere around 1662 around the 1550. Or 1570. So this region, can you see this? Just remember this whenever we are discussing in the amide, that time it can play the very, very important role. Okay, so now one should understand before going to the next segment, alcohol and amine, more or less, we are going to get similar in a type, but any one organic compound, if you are having NH and OH, sorry, NH2 and OH, and it is very difficult to assign for the IR spectrum. That time you have to go in some other spectroscopy to resolve the problem. Next, come to another amine, which is the aliphatic amine. Look at this aliphatic amine, and more or less those who are having the only they can explain IR spectroscopy in their dissertation, or this in a MSc project or in an MPhil project. They can sometime the people, they will say, no, your compound is not formed because there is no primary amine peaks are there. My dearest participant, I'm telling you, you can tell them, okay, sometime these primary amine and secondary amine, you can get very sharp and small peak. Can you observe here? So these are the amine peak. And if the person who can only understand theoretically, he can bias you. Okay, but practically it is not in that condition. Whatever today I'm discussing, it is all about practical segment, not in a theoretical. The theoretical tells in a amine NH2 group, it can give the shoulder peak or strong peak somewhere between 3400 to 3300. But if you take in a simple this amine, I'm going to get the very small peak. In a weak peak, it is a 3600. So that's what this amine and alcohol, it is very difficult to understand in only IR because of their internal structure, like a internal hydrogen bond and external hydrogen bond, and so many other interaction with the moisture and the other bonding nature. So that is what, wherever NH and OH system comes, very carefully you can assign the your structure with help of the IR spectroscopy. Look at this. Next, come to another important the day-to-day when you are working in your chemistry laboratory. That is aldehydes, ketones, and the carboxylic acid. All three containing, it is a polar C double bond O character. That is usual. We can call it as the carbonyl bond. Okay, this carbonyl carbon play important role. If you see the structure of the aldehydes and ketone, one is the sp2 character, another one is the sp3 character. Whereas in a sp2 character, carbon is directly linked with the acidic hydrogen, whereas in a sp3 character, carbon is directly linked with another less polar carbon. Whereas, so this carbon is usually in a polar carbon, and this is the polar carbon, and this attached with another non-polar carbon. Okay, and if you see in acid is the carbon, the polar carbon is attached to another polar compound, oxygen. So this all three, aldehyde, ketone, and in a carboxylic acid, and more or less if you go to the carboxylic acid derivatives, carbon is a very electron deficient. Sometimes I can say it is a polar in a nature, and it can give the very good or informative in a structural elucidation of infrared spectroscopy. Look at this. If you take simple one in a butyraldehyde, I'm going to get in a CH stretch, and the very important one is C double bond O stretch. But look at this, the carefully, sorry, here there is a mistake. It's around 2700. Okay, so if you take C double bond O, we are going to understand somewhere between the 1720 in a reciprocal centimeter. But if you see the characteristic peak at in a CH stretch of CHO, that is the aldehyde stretch. The aldehyde CH stretch, we are going to observe somewhere between the 2700 to 2750 reciprocal centimeter. So this is the one of the major difference what we are going to observe along with the ketone. If you see the ketone we are not going to observe that is in a 2750 or to 2720 peak. But in a C double bond O stretch, more or less, the C double bond stretch, the more or less somewhere around the 1720, and here I'm going to observe somewhere around 1718. But whatever the stretch of in a acidic the proton, so this stretch I'm not going to observe in a ketone. This is the usually most of the time in a MSc or the Viva questions, they are going to ask how you are going to differentiate in aldehydes and ketones with in a IR spectroscopy. Look at this. When you see next comes in a carboxylic acid. I'm not discussing about carboxylic acid as a movement. I'm discussing about the in a C double bond O character and OH character. If you want to discuss in a carboxylic acid, there is a very big to understand how the actually in a carboxylic acid structure and how it play important role of this polarity in nature. But basically to understand OH stretch, what we are going to observe of OH of COOH, that is a broad peak. It starts somewhere between 3500 to 2500 reciprocal centimeter broad peak. But one the very important to understand are most of the time CH stretch of CS3 or CH stretch of CH2, okay, symmetric and asymmetric, both they are merged with this carboxylic acid. But even though sometime if you are taken in a standard condition, what here the author has published, even he can explain, I have got the better CH stretch, it can shows strong peak and come overlapping towards the OH stretch. And more or less the C double bond O character stretch we are observed in a 1700 reciprocal centimeter. But these whatever the aldehyde, ketone and carboxylic acid, when you have taken the standard condition, that time you are going to observe somewhere around 1720 to 1711 reciprocal centimeter. But if you take in a regular condition or in a sometime moisture condition, in a normal condition, most of the time these aldehyde, ketone and carboxylic acid, we are going to get it a little bit lower side up to 1680 reciprocal centimeter, like the 1720 to 1680 reciprocal centimeter, what we observed in most of the practical conditions. Look at this amide. Just in a previous when I discussed in the time of amine, look at this. Here we are one of the important C double bond O character is missing. Okay, instead of C double bond O carbonyl stretch, we are discussing about amide 1 and amide 2. Most of the time, the person, those who are working in a big molecule like a proteins, peptides, and the person is working in a carbohydrate chemistry, he come across most of the time this problem. Okay, so amide, we are going to get in a NH stretch in a symmetric and asymmetric. It is a more what I mean to say better than what I'm going to get in a primary amine. But C double bond O character is overlapping between the NH deformation, or usually we can call, so these two peaks, characteristic peaks we are going to observe, and we can say there is a amide 1 and amide 2 type rather than in a carbonyl and the NH deformation or the bending. Okay, what is the take-home message from the in a simple in a FTIR today? One should understand in a very simple way to stretching and bending of the functional groups. He should take where the stretch is there and where the bend will, and group frequencies. This is a very important. Group frequency means today alkenes, alkynes, alkyl halides, alcohols, ester, carboxylic acid. This the group frequency. Then the spectral comparison makes anybody perfect understanding. You always compare the spectra, then you can get the better idea. FTIR should run in a standard condition, or if your FTIR is not in a standard condition, it is a freely available. If you note it down, there is a www.https there is a esdbs. So this site, it is a freely available. It is a Japanese one. Site is there. Every day you can download n number of the standard FTIR, IR, NMR, and mass spectra, and you can download and you can get the idea. But best way to become to understand better in the one example or one structural elucidation per week or per day according to your. So this is the one important message, take home message for from the FTIR. Is it clear? Any questions regarding this? Audience, I'm just going the monotonous, or any questions? Any questions?
Yes, participants, any questions about?
Yeah.
No, sir.
Okay, whether it's clear or all clear, whether I'm going very fast or is it okay?
No, sir. Okay, sir.
Dinath, you have any
Okay,
question?
fine. Any questions, if anybody, before going to the my next this one, that is a nuclear magnetic resonance spectroscopy.
Dinath, you have any question?
I think
No, sir.
okay.
You may proceed.
If anybody become a little understanding of IR, this one example per day or one example per week regularly he should do, then there is no problem at all. Okay, if there is no question, I'm going to take the next another story of spectroscopy. There is nuclear magnetic resonance spectroscopy. Usually we can call the NMR. It is also one of my favorite area of understanding. When you hold any NMR, this is the just NMR of my own compound. The NMR spectra obtained answer many questions. It will first give the answer, who are you? It will give the answer whether you are the proton NMR, whether you are in a carbon 13 NMR, whether you are F9 fluorine 19 NMR. It will give the first answer to the question, that is, who are you? Second question, where are you located in a molecule? It is another important to understand. Okay, fine, I am the proton NMR, fine. Then tell me where you are located in a molecule. If location will find out, then how many of you are there? Now, then come to the number. Okay, if you know the how many numbers, who and where are you? Where are your neighbors? That is another question. If you ask your NMR spectroscopy, it can give the right answer. Finally, how are you related to your neighbor? Whether you are one bond nearer or whether you are two bond nearer or you are very far away from your neighbor. So these type of the questions answers you are going to get when you hold any NMR, the spectrum. But to understand NMR spectrum, one should know what is the simple meaning, what is the NMR, how I am going to utilize. It is a technique to understand type, number, and relative position of the certain atom present in the molecule. If I am using the proton NMR, I can understand how many types of proton, how many number of protons, and what is the relative positions of the proton. If I am working on C13 NMR, then type of C13 NMR, how many number of in a carbon, and how the carbon they are relative positions. I think those who are working on NMR, these spectrum, they might have seen. This is a first spectrum of the water. The Bloch, he has published in the 1946, the very important in physics review. This is the first in a spectrum of the FTIR, in a NMR. Okay, who has published Bloch has published in a physical review in 1946, and most of the people and most of the article, it's said to be this is the first NMR spectrum. Afterwards, this in a very small and without have any knowledge or very less information, in the 1956 or if I say 1951, the Arnold, he published the very important in a IR in a NMR spectrum of the ethanol. And recently, most of the people, if you are working, I have just given in a NMR of the ethanol in a 1951 along with the 2011 or sometime you can say in a 2000. Okay, how it is a difference from the if you say anybody in a 2000 we are working on a 2Z Android system. Now it is somewhere in a Android 10. It is same way. In 1951, it started and very well resolved. We are going to get in a last decade. So nuclear magnetic resonance or NMR play important role in a nowadays in a medical on the health. Basically, it has been invented by physics person. It is invented by physics person, developed by chemistry person, and enjoying or taking the what I mean to say, enjoying in the medical people. And this is the one instrument have received more than in a couple of or 5 Nobel Prize in or it started with a physics, chemistry, and medical. One instrument grab the interdisciplinary area in a Nobel Prize, that is a NMR. And recently in 2002, they have got the Nobel Prize on the basis of nuclear magnetic imaging, that is a MRI. And way back to 1966, it has been published FT, that is a Fourier transform. So this Fourier transform, they converted time domain to frequency domain. This is the very important milestone of the FT NMR. It starts in 1966. They are the first the conversion of time domain to the frequency domain. Little bit theory, or I can say some principle. The people, those who are understand, most of the time they will ask in a resonance, or what is the if you say these are the how NMR works and other things. If you remember in a childhood, you might have played in a normal in a magnet. Okay, just I'll open this video. I'll show something. Can you see what I'm holding? Can you see? This is simple. Your child used to play in a normal magnet. Okay, I'm just holding all these. So these magnets, they act as a how they are. They are in a what I mean to say, in all the direction. They are not in a homogenized. Okay, look at this. So if you take the proton also having the electric charge and having the momentum, if any one molecule having the electric proton and neutron, it is having the very important characteristic as a magnet. And the one tiny magnet, when I say in a proton, it act as a tiny magnet, and almost that tiny magnet also it act as a whatever you are the magnet it does. This one. Okay, look at this. So what happens when you want to say this all protons, they act as a tiny magnet, and they are having both charge and as well as momentum. So then they form a magnetic character. If the magnetic character they are without any external magnetic field, and these magnets or these protons, they are in a non-homogeneously they arranged. But when you when you apply the external magnetic field, there is a B naught. When you apply the external magnetic field, so that time, so these protons, they are become in a two state. One is the lower energy state, another one is the higher energy state. It's exactly in a Planck's constant E, delta E, there is a energy difference. Usually in a lower energy, whatever the in a proton or lower energy in a, usually we can call alpha spin, and higher energy in a protons or higher energy in a protons we can call in a beta spins. What exactly happen in a resonance? Just in a 1 minute I can tell you. The NMR absorption, or usually we can sometimes the people they will ask what is the resonance. A molecule is in a resonance when it is irradiate with a radio frequency photons having the energy equal to the energy difference between the spin state. Under these conditions, proton in this state can absorb the proton and flip to in a beta state. That's what. If you apply the any then radio frequency, that radio frequency of the equal frequency or same frequency of the energy difference between the two spin state. If same energy you are having the radio frequency, and whatever the frequency between lower energy to higher energy, then whatever the lower energy spin state or molecule, it will absorb and it will go to the higher state. So this state usually we can call flip state or resonance state. Okay. This is another way to represent it in some pictogram. They are in a different magnets, are different tiny magnets, are different protons when they are in a randomly distributed. When you apply the external magnetic field and they are going to definite rotation either in alpha state or beta state, Okay, alpha state is the lower state and the beta state is the higher state. And usually this, whenever you are apply the radio frequency, which is the equivalent to the energy difference between the two state, then the molecule are going to absorb the radio frequency. Then whatever the lower frequency alpha states, they are going to flip or they are going to in a beta state. So this is the usually we can call it as a resonance. Okay. Now let us. I'm the little bit optimistic. I can say you can just little understand about how exactly NMR works and other things. You have a more concentrate on in a structural elucidation. And if any one person, if they brought IR spectrum or NMR spectrum, you should able to interpret that rather than how NMR works, how IR works. Now these are day that is a cup of any technician can do the things better than anybody. But it's our duty to understand how how anyone can interpret better. How can you say whether this molecule is X or this molecule is Y? That is important in a present need of the hour. Okay, you can say next before going to the one should understand what are the different types of protons, or what are the different types of environment, or what are the different types of magnetic environment one compound having. To understand, there is a simple one question they are going to ask if you go to the any William Kemp or Silverstein, how many proton environment are there in a ethanol, are there in your compound? If I say this is the CH3, CH2, OH, there are 6 protons are there. Whether all protons they are in a same environment. If they are in a same environment, and it is a very difficulty to the structure elucidate. That's what physics person they are telling. It is not in our cup of tea. Physics person is tells if anyone the character, anyone compound character, it should be same at any other given conditions. But if you take in a NMR, so these protons, even though they are the protons, they are in a nature, they are environment, they are in a different as compared to in a physics concept. Look at this. If you take these terminal CH3 peaks, okay, they are in a one environment. The central CH2, they are in a second environment. Third one is there is a hydroxy group OH, that is a in a hydrogen is attached to the oxygen, that is having the another environment. If I say there are 3 types of protons, they are present. So that means 3 types of different signals I'm going to get rather than one signal. But if you compare in a simple benzene, if you take in a simple benzene, if anybody asks the how many types of proton is present, okay, you can say there is a 6 type of protons. No, is only 1 type of the proton. That's what I told you in a IR. In a carbon-carbon double bond character in a benzene, it is 1.38 rather than 1.53 or in a 1.34 angstrom. It acts as a 1.5 bond character, and all 6 protons, they are the sandwiched between, that is a ring current. The simple, if you take the benzene, I can get only one signal because all 6 protons, they are in a same environment, whereas ethanol having also 6 protons. So these 6 protons, they are, I'm going to get in a different signal because these 6 protons, they are present in a different environment. Basically, they are the 3 environment what we are going to observe. Look at this. If you want to see, just now I talked about in a benzene. Apart from benzene, if you take in a cyclopentane, tetramethylsilane, and acetone. So these all of protons in a molecule which are chemically identical environmental, okay, will often exhibit the same chemical set that it shows one signal in an NMR spectrum. Okay, but if you see the proton in this case said to be chemically the equivalent. But if you take in other compound like paraxylene, if you take from in esters, if you take in ether, if you take the acid chlorides, if you take the other compounds, these On the other hand, these molecules, they are set to proton which are chemically distinct. Okay, distinct means they are different. How the different in a chemical environment from one to other, it can give the different absorption signal. The one should know before going to the in a structural elucidation, you can write a probable structure. From the probable structure, one should understand how many types of the protons are available and what is the characteristic of proton. And next, whether these protons can I assignable protons. Sometime these aromatic protons, if you are having the aromatic compounds, more or less they are in a merged with a one to other peak. Then you have to see whether is there any assignable functional group peaks which can say my compounds are confirmed in a whatever I expected in any way. Next, come to if I say how to distinguish between these protons. If you see to interpret or predict the NMR spectrum, one must first be able to classify the proton. Just now what I told and their environment. If you see in a red proton, which I make, if there are two proton, if you remove the one proton and you substitute one group, and if you replace in a one blue proton another in a group, then these are in a different chemical set, because they are in the most of the time these are the in a different molecular type. But if you see in a homotropic in a proton, this homotropic proton, even there is a change in a position of the terminal group, we are not going to get any different in a chemical set, because they are in the same chemical set what we are going to observe in a NMR spectrum. Look at this. If anybody, if there, you can get these in any book, but one should understand sp3 hybridized and sp3 hybridized along with the double bond character, along with the C double bond O character, along with another heteroatom in a sulfur character. One should know, and these compounds we are going to get 1.5 to 0.2 or 0 in a reciprocal, sorry, in a delta ppm. Okay, but sp3, the very important when I am going to say, we are going to observe 0 to 0.22 or 2 reciprocal, or when you say in a spt, sp3, sp hybridized. So these are combined, you can get the delta 3 ppm 2 and delta the 0.2 ppm we are going to observe. Look at this. Next come to in sp3. Even these sp3 attached with halogens like fluorine, chlorine, bromine, iodine, some of the other heteroatoms like oxygens and nitrogens, we are going to observe somewhere between delta 3 to 5 ppm. And afterwards, this NHOH, we are going to observe in between 0 to 5. And once again, my dear participant, it is not a right. And I'm going to give you most of the example in a practical. If these are, if you take the standard condition and the standard only we are going to get in a 0 to 5, most of the time when you are going to do in a heterocyclic compounds along with the NH and OH, we are going to get in the different form only. But olefinic in a like alkene H, here the character is a sp2 character. Hydrogen is present above or below the carbon doubly bond character. That's what they will go to the de-shielding. It can goes up to the 4.5 to 7 ppm delta ppm and more. Everybody knows in aromatic we are going to get in a somewhere between 7 to 8.5 ppm, along with the chloroform, what we are going to get the very in a normal or common solvent used in a NMR solid samples. Aldehydes peak we are going to observe at 9 to 10. Okay, this is the another important peaks what we are going to observe in a characteristic peaks of carboxylic acids, and we are going to get 10 to 12. So if you see the protons in an electron rich environment, usually we can call shielded and low frequency small delta value. But any protons, they are in a poor electronic environment, we can call it as a de-shielded, downfield, high frequency and large delta values. And these things we can get some of the internet sources. It is a open web source, it's available. Next, come to, if you take some in a structural elucidation or interpretation, starts with a simple alkyl halide. In a alkyl halide, if you consider what are the types of peaks, what I'm interested about blue proton. I'm interested about the blue proton, where the blue protons they are going to appear and how it is going to appear. According to n+1 rule, according to the n+1 rule, so it will give the triplet, okay, the very important, and this will give also in a triplet, okay. But what about this CH2? Okay, this CH2, they are going to give the pentet. When you see, you can observe 1, 2, 3, 4, 5, 6. Okay, 3 plus 2, 5 plus 1, that is according to the n+1. I'm going to get 6-line character. I'm going to get the 6-line character. So the 6-line character is the important to understand according to the n+1 rule. These are the normal in a NMR spectrum, which can very easily you can identify. Along with some alcohol, in alcohol also what we are going to observe in in a internal or central CH2 peak. So this central CH2 peak, once again, I'm going to observe an 6th line because of this 2 proton, and here is a 3 proton, and in the sandwiched between these 2 and 3 proton, I'm going to get the 6 lines of the proton. And one more important, the peak, I'm going to get the OH somewhere between the 1.6, and it can be understand when you are using the D2O exchange. Apart from this, the one can say why this CS3 peak we can get in a upfield, and this CH2 peak we are going to get in a downfield. Look at this. If you take anyone, it is a very important topic in a NMR, that is whatever the factors affecting the chemical shift or the in a proton NMR. So this whatever this oxygen is act as a in a electronegative atom. It try to pull the electrons from the carbon, and that carbon is the, once again it pulls the electron from the hydrogen. That time the carbon is act as electron deficient, whereas the hydrogen also it act as a neighboring to the carbon. Whatever the hydrogen attached to the electron deficient carbon, so those hydrogen or those protons we are going to observe de-shielding rather than shielding. So that's another important point one should know before going to the structural elucidation. What is shielding and what is the shielding? Any one compound attached to the carbon, and any one proton attached to the carbon, any one proton attached to the oxygen, attached to the nitrogen, and attached to the sulfur, how they are going to act. It is on the basis of electronic cloud or electron the deficient. If more electron deficient, so these protons they will come to the resonance at in a downfield rather than in a upfield. Look at this. This is the simple one, acetone. We are going to get only single peak. Why I'm going to get the single peak? Because the all 6 protons they are in a same environment. So that's what I'm going to get in a one peak at the somewhere between the 2.2. But I'm going to observe there is a small peak over there. So this peak is in a chloroform, because when you take, this is the original in a spectrum, you are taken as a CDCl3 that usually we can observe to 7.24 to 7.25. Okay, look at this. In a same in a ketone, if you are performing in a cyclic or in aromatic, we can observe in a different way. Look at this. These whatever the terminal, I'm going to get the singlet. Okay, why I'm going to get the singlet? There is no in a neighboring proton. The whatever the proton, if you see, there is a, these are neighboring protons, and which can have in a spin-spin splitting or spin-spin coupling. But here you are not going to get the coupling between, so these protons and these protons, okay, only these proton coupling is not possible, but this is the possible only whenever in a higher condition there is a NOE, nuclear overhauls effect, and some of the in a higher condition you can observe, that is the in a complex structures to elucidate HMBC and HMQC. That time we are going to understand this how in a ortho and in a any one compound they are going to have intermolecular hydrogen bond. Usually we can understand there is in a salicylic acid and other things we are going to observe any such small in a hydrogen bond character. But look at this. If you see it in simple in acetophenone, okay, because of if you are having the this group attached to the benzene, and these benzene we are differentiated into the another 3 type of the structures. Look at this. If you take this acetophenone is attached to 1 carbon, and adjacent to the 2 carbon we can get there is a ortho to each other, and these are the meta to each other, and this is the para. So that's what we are going to get 3 different types of the signal. So these 3 different type signal, usually we can get doublet, and usually in a doublet and triplet, or in a doublet and multiplet. So these doublet usually in a proton, it is a very important blue proton what we are going to observe, and then come to in a magneta, then we are going to get red protons. So these type, it is a one can very easily elucidate of the acetophenone, how they are. And most of the people, they are wrongly distributed over these type of the hydrogen. And usually these type of the hydrogens, they are in the same, but they are having the coupling constant with these protons. Look at this, aldehyde protons. Another important one is aldehyde protons. And these aldehyde protons, we are going to observe somewhere between 9.5 to the 10. But here, when we are having the simple in a furon or in a 2-pyrrolidaldehyde, okay, this CH of CHO, we are going to observe at 9.8 the delta ppm. And even the author has published very nicely, there is an impurity of chloroform. Most of the time when my students comes with a lot of these small peaks, usually you can called junk. And even we can observe when you are having the 600 megahertz and 500 megahertz NMR, you can understand the small peaks. And these small peaks, when you take in a 300 megahertz, you are not going to observe any such peaks. And then come to ester. In a same, if we acetone, we have got only 1 peak, and ester we are going to get the 2 peak. And how these CS3 terminal peaks, this is the blue and black, where we are going to observe. If you see both they are attached to the carbon, but this CS3 proton, they attach to the oxygen of the ester. So that's what it can get very nearer to 3, and whereas you can get the methyl protons, you are going to get in this segment. Okay, so before going to the next this one, I can say we have discussed the very fast and little bit in a proton NMR, and then come to the case study, and this is the very important day-to-day the one can understand. Most of the people, I think you are working on chalcones, and afterwards pyrazoles. 99% if you go to the paper, they are published without properly elucidated. Most of the people, they elucidated only in either proton or only in IR. But if you take in a normal IR spectroscopy, it is very difficult to assign. Whatever the IR spectroscopy, I required in a NH peak, okay, it is there, okay, because of moisture in a Belgium condition, and I am having the C double bond O character, and this C double bond O character also I am having. Okay, whether there are lots of unassignable peak because of they are in a normal condition you have take, and they are in a fingerprint region. But according to as a one organic chemist, we can go whether I am going to get in a required peak or not. Then we have gone with a proton NMR. In a proton NMR also, we have got very good in a spectrum, but there is a challenge we have observed. So whatever the NH, it is a very important NH, either in a tautomer, it is a OH. So we are going to get this peak. It is a very important and it is a assignable peak. But very interesting, these peaks, it is made us to challenging. Okay, what are these peaks? And these peaks, when we spoken to some of the NMR person, he told, sir, most of the time these peaks are in a water peak if we are not taken properly. But more or less, when we send the same into the 300 to 400 or 500 megahertz, still we have got these two peak. But when we observe in a different way, we have got some of the literature search also in most of the organic chemistry literature. So these are nothing but H and OH, and these two are OH. Okay, then come to in mind, what is the exactly, instead of chalcone or instead of alpha beta unsaturated compound, what it has happened? So it has happened actually this compound rather than this compound. Okay, so that is a very important to assignable in a proton. So this proton I can get the very simple multiplet and other things, and OH and the H. And even though we have observed this in a better way, when we optimize in our procedure and we have sent once again, so that time we have not got any the such peak. Okay, still we have got, there are small chunks over in a previously, but the major peak we are missing. So that means if you go to the any in a Google Scholar or any in a journal, without understanding the final structure of chalcone, they will publish. My sincere request to most of the time, they are hydroxyketones rather than chalcones. If we are not properly optimized the condition, most of the time simple Skadel-Smith reaction, if we not neutralize properly, or if you made a basic, or if you make acidic, what are the changes? And these changes what we are observed in our day-to-day publications. Okay, so finally we'll come to know in our laboratory, rather than chalcone, we have got in hydroxyketone compounds. And these hydroxyketone compounds also, if you go back 1950 to some of the 1970, the most of the people, they have published this. Okay, then come to, we have gone in another study. If you take a simple normal in FTIR spectroscopy, whatever the one Easter, it has gives whatever the requirement peak at NH and OH. And this we are further characterized by in a proton NMR. We have got very characteristic peaks of the in a methyl ester. It is a characteristic peak of the methyl ester and characteristic the structure of the NH group. And this NH group is the additional group over the whatever the quinoline structures what we are having. And this further we have gone with hydrazide. And in hydrazide, most of the time IR spectrum can give the equal or same spectrum as we observed in a previous spectrum also, because most of the time now we are taking the normal condition of the spectrum. We have done this in a hydrazide, and that hydrazide we have sent to NMR. We have got very good vanishing of methyl ester and formation of NH2 primary amine, and along with the secondary amine and two secondary amine. That is a one characteristic of amide, one characteristic of amide, and one characteristic of secondary amine, and one characteristic of primary amine. Whenever your amine and amide systems are there, I'm requesting to better to go in a D2O system. If you go to the D2O system, we have got the very freely, there is no in a NH2 peak, and there is no primary and the secondary, the NH. So this confirms our compound is in a very good, it has converted into in a hydrazide, and it is a simple started with the SN1 type of the reaction, 4,7-dichloroquinoline and methyl ester. Then that methyl ester we have converted into hydrazide. And when you see this in a hydrazide, we have just compared with this one. Okay, so these are NH2 group, NH, and when you take the D2 exchange, they are missing. This is the best way to, that's what in a take-home message in a last in a IR tool, comparison. And always comparison makes you more perfect. Whenever you are doing any IR and NMR structural illustration, always take the previous step in a NMR and IR. That can help you. That is the best way to understand retrosynthesis also. Look at this. Afterwards, we have done some in a simple skip space reaction. In a skip space reaction, there is an important primary amine. So this primary amine should vanish. So this primary amine should vanish when I want to replace this NH2. So that we have got in a very nicely. There is no in a NH2 peak we are observed, but apart from NH2, and we have got some additional the characteristic OH peak of aldehyde, and the other peak we are going to get. Can you see the small? Sir. Yeah. Okay. Fine. Thank you for your no IR and structural illustration is not a. It is completing in a half an hour or 1 hour or 1.5 hours. Okay. From this, I'll just stop the my lecture. If anybody any questions is there.
Yes, dear participants, if you have any queries or questions, you are most welcome.
Hello.
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 Yeah, go ahead, sir.
Yes, any queries, any questions?
Yes, participants, if you have any Devkar sir, please.
Okay, anyhow, final 1 minute, I'm just giving the glance. In our this one department, we synthesized more than 250 in a quinoline derivative, some of the, in that around few compounds, they shows very good antitubercular and anti-cancer activity. And some around 3 to 4 compounds they showed in a lead active, and these are some references. And I'm just standing in front of you because of these people. And this is a now new team. Like just one Preeti Salvesi is completed in a full-time PhD under me, and she published very good paper. And presently there are another young people, they are joined me. She is Rohini, and she is working very hard. And another one is a young person, people like Vaishnavi, hard work from 9 to 9. If I say something without asking what, why, when, Vaishnavi is another, and next come to Nand Kishore, and another young guy is the Ram. This is my new team of the, apart from some other people are there. This is my team, and thanks to GCP Karad, thanks to Kelly College of Pharmacy, Belagavi to give. And this, whatever this work I'm giving, Rohini, Preeti and Prajakta, actually now is a, how to interpret the IR NMR, it was there. No problem, sir. Next, whenever time is there, we can have this. Dr. Manu sir.
Yes, sir.
Yeah, over to you, sir.
Yeah, thank you very much. Madam, please.
Yeah.
Yes. Thank you very much, sir. So thank you very much, Dr. Alegaokar sir, for your excellent presentation on problem solving using FTIR and NMR spectroscopy for structural elucidation in pharmaceutical chemistry. In this session, sir has wonderfully explained the theoretical principles in FTIR and NMR in a very simplified manner, giving emphasis on practical aspects. Sir has very well elaborated the interpretation of FTIR spectra of different chemical compounds, as well as the principle of NMR spectroscopy with examples such as alcohols, alkyl halides, ketone, and others. Sir has nicely explained how to interpret both the spectra, FTIR and NMR spectra, using case studies, which will really help us in structural elucidation of the compound. So, on behalf of the organizing committee, I extend my sincere thanks to you, sir, for accepting our invitation and sparing your valuable time for today's session. Now I request Professor Gawane sir to offer Alegaokar sir the certificate of appreciation.
Thank you, madam. Okay.
So, thank you, sir. Thank you, Gawane sir.
Thank you.
So again, thank
Yeah,
you very
thank you
much,
very much.
sir, for your excellent talk. I'm sure your today's presentation will definitely help all the participants as well as PG students to understand these techniques, these concepts in a better way and help them
Okay.
in their future. So thank you
Okay.
very much. On behalf of organizing committee of GCOPK, we extend our
Okay.
sincere thanks for your valuable effort. Thank you, sir. Thank you very much.
Thank you, madam. Thank you, madam. Thank you very much. Okay.
Thank you very much, sir.
Yeah, yeah. Can I leave, sir, now?
Yes, sir, you may leave, sir. Thank you.
Yes, yes. Thank you, sir.
पांडे सर
We will start with our next session. Yes, sir. Yes, Gawane sir.
हा सर पांडे सर आहेत ना पांडे सर आर यू देयर हा पांडे सर स्क्रीन शेअर केला तरी चालेल
ओके सर ओके 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 राईट ओके मला हे राईट्स नाही आहे तिथे सर प्लीज
ओके
होस्ट करायचंय का?
हो सर पांडे सरांना पोस्ट करायचं
हा, केलाय.
हा सर
स्पीकर एकच मिनिटात जॉईन होत आहे. सुरू करूया लगेच.
ओके सर स्लाइड शेअर करा ती
हो 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 करतो
Lokapure sir, have you joined?
Yes, sir, join.
Yes. Pandey sir, you may start.
Okay, thank you so much, sir. Good afternoon, everyone. So we are at our last session of today's day. So today we are having Mr. Sachin Lokapure sir with us. Let me introduce briefly about sir. Sir has completed his M.Pharm from BLDA College of Pharmacy, Vijaypur, Karnataka in 2012. He is currently working in Appasai Birnare College of Pharmacy as assistant professor. He has 9 years of teaching and research experience. He has total 18 national and international publications. He has participated in over 25 conferences and delivered seminars as a guest lecturer. He has granted over 40 patents and few patents are filed. He also provides service as a patent consultant. He is professionally affiliated with IIT Madras for research and development work. He has been awarded by India Book Records and Limca Book of Records for most number of patents granted for decision. So actually it is a very interesting biodata of sir, and in very few years he has filed so many patents and also got awarded. I request Dr. KB Burade sir to please welcome Sachin sir with a bouquet. Okay, thank you so much, sir. I request Sachin sir to start with the session.
I will share my PPT.
Yes, sir. Yes, sir.
Okay, good afternoon, everybody. My slide is visible, sir?
Yes, sir.
Yes, sir.
Okay. Today I'm going to discuss details about the microscopy, the digital microscopy. Actually, this Saglo research equipment is my company manufacture this digital microscopy. So from 2014 to my company granted
तुमचा आवाज थोडा अडकतोय.
249 patents.
सर तुमचा आवाज थोडा ना अडकतोय, म्हणजे असं इंटरनेट कमी असल्यासारखं वाटतंय.
Okay, एक minute. येतो आता आवाज?
हा, आता येतोय. Yes, sir.
Okay. So this is my company, Saglo Research Equipment, which manufacture a digital microscopy. So from 2014 to till date, we granted 240 patents, design patents for different microscopy and microscopical techniques. So nowadays in the market, you get a different type of microscopies. First is a regular microscopy or regular microscope, which is used by students. Second, the research microscope. So nowadays the research microscope is modified with the digital one. So in that microscopy, they added some cameras and some softwares. So we develop a special camera and special software, sophisticated software for research purpose, for student, for research publications, for diagnostic and some other things. Okay, second slide. So first time in 2014 granted a bright field microscopy. In 2015 we granted patents for digital adapters or digital cameras. Then we developed a real-time video microscopy in 2016, and in 2017 we granted patents for microscopy and integrated tablets, which is attached to the microscopy. So in that particular project, you don't require any separate computer or system for the microscopy. Next is in 2018, we develop a special advanced version microscopic software for analysis, diagnostic, and for research purpose. And in 2019, we granted dark field filters, or it is called as removable filters, which is applicable to all type of microscopy. That filters we are developed and granted patents in 2019. And 2020 recently we developed a new compact inverted microscope. It is called as a nanoscope. We just try to touch with the nanoscale in the light microscopy. तुम्ही बघू शकता की लाईट मायक्रोस्कोपी मध्ये सध्या तरी 1000x पर्यंत, म्हणजे 1 मायक्रॉन पर्यंतच पॉसिबल आहे आपल्याला जे काही ऑब्जेक्ट बघायचे असतील तर. पण ते जर क्रॉस करायचं असेल किंवा ॲबेचा जो काही लिमिट आहे मायक्रोस्कोपीचा, तर नॅनोस्कोपी पर्यंत जाणं गरजेचं आहे. तर आम्ही नॅनोस्कोपी नावाचं एक आता ऍडव्हान्स वी डेव्हलप मशीन्स द मायक्रोस्कोपी विच गिव्स you particularly 10 nanometer 50 nanometers पर्यंतचे जे काही रेंज आहेत, we can easily observe and analyze under this particular microscope. So this is our model. The first is SGL-11A is a trinacular bright field microscopy. Then 11B is a digital microscope with camera and tablet, and 11C is a bright field inverted phase contrast, inverted dark field, and inverted fluorescence microscopy. And we also provide some USB cameras, separate cameras. It is applicable to all standards trinacular microscope or other trinacular microscope. And the professional image analysis means Cyclosoft micro imaging is our software suite for professional image analysis or image development and microscopy. So we provide 4 important good criteria or good things in the microscopy. First is suitable for all universities, experts, and routine labs. So The equipment is very sophisticated, easy to handle. Software is also sophisticated and easy to handle for end user and customers. Then we provide excellent prices, minimum prices with the performance ratios, with the different type of objectives. It is called as achromatic objectives. आता जे मार्केटमध्ये मायक्रोस्कोप्स अवेलेबल आहेत त्याच्या ऑब्जेक्टिव्हचा प्रॉब्लेम हा असतो की तो अक्रोमॅटिक नसतो अँड अँटी फंगल नसते. वी प्रोव्हाइड अँटी फंगल अँड अक्रोमॅटिक लेन्स. सो व्हॉट इज अँटी फंगल अँड अक्रोमॅटिक लेन्स? म्हणजे त्या लेन्सला एक स्पेशल कोटिंग केलेला असतो जो नॅनो कोट असतो. त्याच्यामुळं कुठल्याही प्रकारचं रस्ट अँड फंगल्स डिपॉझिशन्स त्या लेन्सवर होत नाही. त्यामुळे लेन्स just you clean the lens, you get new type of lens at every time. Next, we develop a new breakthrough Windows tablet or particularly tablet attachment to the microscope. It is suitable for in situ type model. We have to use the microscope and tablet for the observation for operating the softwares. Then we provide a dark field microscopy. So this dark field microscopy is important for a diagnostic purpose. The first is malarial diagnostic for nano protein observations or nanoparticle observations or particle size determination. In that you can observe the dark field microscopy. Okay, so that time we provide ultraviolet light source and blue filters and plus some key points also we are also added in the software for direct conversion of bright field images to the dark field image. So next important is LED illumination technology. Nowadays most of the microscope is integrated with the halogen lamps. So problem of halogen lamps means एक तर ते गरम होते आणि दुसरं म्हणजे ते जे लॅम्प्स आहेत त्याचा लाईफ स्पॅन हा लिमिटेड असतो. अँड दिस हॅलोजन लॅम्प गिव्स अ येलो बॅकग्राउंड अगेन्स्ट colored samples. So no one can justify or identify, differentiate between the two cells or two colors of the cells, especially for observation of genetic materials. मियोसिस मायटोसिस जर ऑब्झर्व करायचं असेल तर त्यावेळेस त्यातले जे काही स्ट्रेन्स आहेत, क्रोमॅटिन नेटवर्क्स आहेत, त्याचे काही स्ट्रेन्स, त्याचे स्टेनिंग्स आहेत, ते जर ऑब्झर्व करायचं असेल तर बॅकग्राऊंड व्हाईट असणं गरजेचं आहे. दॅट्स वाय वी डेव्हलप एलईडी टेक्नॉलॉजी. सो इट इज कॉमन टेक्नॉलॉजी. काय असं काही याच्यामध्ये रॉकेट सायन्स नाही, बट वी डेव्हलप अल्ट्रासोनिक बेस्ड एलईडी टेक्नॉलॉजी. आता हा टेक्नॉलॉजी काय आहे की जो काही लॅम्प आहे हा लॅम्प त्या लॅम्पला आम्ही टायमर इंटिग्रेटेड केलेलं आहे. त्यामुळे असं होतंय की जर समजा एंड युजरनं जेव्हा मायक्रोस्कोप चालू करतो त्यावेळेस तू लॅम्प चालू करणार. लॅम्प चालू केल्यानंतर युजर एक 15 मिनिटसाठी तो लॅम्प वापरणार. ऑटोमॅटिकली आफ्टर 15 मिनिट्स द लॅम्प इमिजिएटली स्विच ऑफ. Then if you want to again switch on the lamp, just you have to put hand behind the microscope. Immediately the microscope switch on the lamp. It is called as ultrasonic based cutoff system of LED illumination technology. याच्यामध्ये कुठल्याही प्रकारचं आम्ही लॅम्प स्विच ऑन आणि स्विच ऑफचं आम्ही बटन दिलेलं नाही. त्यामुळं आर्टिफिशियल इंटेलिजन्सचा यूज करून मायक्रोस्कोप ऑटोमॅटिकली स्टार्ट अँड ऑटोमॅटिकली स्विच ऑफ द लाईट. त्याच्यामुळे काय होतं की एलईडी लाईटचा जो काही लाईफ स्पॅन आहे इट इन्क्रीजेस अँड इलेक्ट्रिसिटी कन्झम्पन्स हा सुद्धा कमी होतो. ओके, दिस टेक्नॉलॉजी वी डेव्हलप्ड इन सायक्लो इंडस्ट्रीज. So the first model, our first model is SGL11, is a trinacular bright field microscope. So this microscope is a regular trinacular microscope integrated with the digital cameras. So basically we are digital microscope camera manufacturer. So apart from we develop other accessories of microscope, means the whole microscope and the binocular and trinacular. So this model shows a trinacular microscope with LED illuminations plus slide cleaner system plus digital cameras. Also we provide a software suite, version 1 and version 2 for observation of different microscopic images and their analysis. So we provide observation model as a bright field. Then we provide a chromatic lens we provide eyepieces 10x and 20x with the coated lens, then achromatic lens. Then we provide objective N plane 40x, 10x, 100x, 5x with achromatic and antifungal lens. Then we provide a proper and sophisticated focusing system as a coarse adjustment and fine adjustment knobs plus stage adjustment. Then we provide illumination systems, means LED illumination system plus artificial intelligence based ultrasonic illumination systems plus different type of filters like dark field filters, bright field filters, and inverted phase contrast filters. We provide all these accessories with this microscopy. Then our second model is a digital microscope with integrated camera and tablet. So this is similar model as like a trinocular microscope, but here we attach the tablet for observation of microscopic images at same time, same place of the microscope. You don't require a separate a microscope or separate computer system or separate Windows system. We integrated Windows system to that microscope itself. Okay, so the features of this particular microscope is it is a simultaneous camera and power connections and the tablet connections, then equipped with latest Windows operating system and Intel processors. Then we attached or integrated advanced our Saglos software suite version number 2 in that particular device. So this particular device is patented by our company. Second is bright field inverted microscope. So this particular model is based upon the inversion type of microscope. So he जी inversion type of microscope है, हे cell culture. This particular microscope is applicable in cell culture or tissue culture laboratories or for the detection of anti-cancer activities or the vials and plates observation directly under the microscope. So in that microscope, we added the three basic component of microscopy. The first is bright field, second is in dark field, and the third is the fluorescence. So according to the customer, we provide that technology. Otherwise, sometimes the customer require three technology in one microscope. We provide this three technology in one microscope. So it depends upon the requirement. So this particular microscope shows the light or particularly source of the light is upside the positions or upward the positions, and the lens system is downward the positions. And it shows the two binocular system and one trinocular system. So on the stage, you have to directly place a plate or particular evacuated bottles, culture bottles, or the plates or the vials, whatever you have to place on that particular stage and directly observe under the microscope. So here I given the three images which is captured from the devices. This is the cell culture, cancerous cell culture. It might be the breast cells cancer cell line, and the second image shows the lungs cancer cell lines, and third image shows the brain cancer cell line. So here the three images shows the in bottom last image shows the bright field image. So this bright field image captured from the bright field microscopy. The left side image shows the dark field microscopy. So this is captured from the dark field inverted phase microscopy, and top one image shows the phase contrast inverted phase microscopy. Okay, so what is the difference between these three? The bright field is a common technology or common microscopy, but the dark field shows the nucleus is glowing under this microscope. So one can observe the nucleus or nucleus fusions or nucleus cell division. One can observe under this dark field microscopy. And upright position ला जे आहे, जे phase contrast, याच्यामध्ये तुम्ही observe करू शकता की the background is somewhat dark and total whole cell is glowing. जे dark field मध्ये आहे त्याच्यामध्ये त्याच्यामध्ये whole cell is glowing. त्यामुळे सेलचे एजेस, what is a cell structure, cells you can observe under this particular microscopy. So next is a digital cameras or digital eyepiece. So when you see under the microscope by using the eyepiece, that time you manually observe. So we convert this manually observation into the digital one. This is called as a digital eyepiece. You can insert this digital adapter or eyepiece into the microscope, any type of microscope or any brand of microscope like Olympus or Micro Optics or any type of microscope. It is suitable for all type of microscopy, and you can capture, observe, record microscopic images. You can validate and you can generate the reports by using this adapter. Okay. Next point is our. So we put two type of software suite: Cyclosoft software version 1, Cyclosoft software version 2. In Cyclosoft software version 1, we provide a login system, then report generation system, then making organization or making a name of the organizations. Then we provide image capturing, recording images, and particle size analysis. And for pathological department, we provide different type of diseases and their image capturing and their report generations. All this part coming under the software version number 1. Okay, you see here, this is the software number version 1. So when you enter into the microscope, you first of all get a Windows, then go for capturing the image, select the cameras, go for capturing the image, then capture the image. You can save the image, then export the image. Second is you can record the different type of videos, microscopic videos like bacterial motility, then cell division, then any movement under the microscope you can capture and record it and save it. And second is for pathological, you can generate the pathological report. For example, if this software is given to any pathologists easily can generate their pathological report by using this microscopical test. For example, if the patient come for malarial diagnostic, malaria patient आला तर त्याचा blood असेल, the blood, when you observe the blood RBCs under the microscope, you see that you can easily see the spot of a malarial parasite present in that particular cells. Then you can capture and make a report the malarial cells present and report is positive. Such type of all pathological reporting system present in the software. So this particular software number version 1 is sophisticated for pathologists and for a general researcher or for the students. And our second software version number 2 software suite is applicable or it is useful for the higher studies like research, postgraduate, PhD students in the pharmaceutical industries or in microbiological research, in biotechnology, in herbal technology. In that particular field, the software version number 2 is used. So what is software number version 2? This is the software version number 2. So this we design on the basis of the 21 CFR of US FDA norms. So what is the 21 CFR US FDA norms? ते नॉर्म्स काय सांगते की कुठलंही जे सॉफ्टवेअर जेव्हा आपण डेव्हलप करतोय, बायोलॉजिकल सॉफ्टवेअर म्हणजे डॉकिंगचं स्टडीचं सॉफ्टवेअर असू दे किंवा मायक्रोस्कोपीचं असू दे किंवा एनी HPLC, HPTLC, वॉट एव्हर, ज्या इक्विपमेंटचा जो काही सॉफ्टवेअर आहे, दॅट सॉफ्टवेअर कंप्लाइज विथ द 21 CFR ऑफ US FDA नॉर्म्स. म्हणजे काय की त्याला लॉग इन सिस्टीम असणं गरजेचं आहे, पहिला पॉईंट आहे. दुसरा पॉईंट म्हणजे जे काही आपण त्याच्यामध्ये काम करणार आहे, व्हॉट एव्हर HPLC, HPTLC किंवा मायक्रोस्कोपी मध्ये जे काही इमेज कॅप्चर करणार आहे, दॅट इमेज इज नॉट एडिटेबल पाहिजे, एडिट करता यायला नाही पाहिजे. दुसरं म्हणजे त्याचं रिपोर्टिंग व्हायला पाहिजे. मीन्स यू कॅन जनरेट द रिपोर्ट बाय युझिंग दिस सॉफ्टवेअर, व्हॅलिडेशन व्हायला पाहिजे अँड ऑथेंटिकेशन असलं पाहिजे. व्हॉट इज ऑथेंटिकेशन? जे काही रिपोर्ट होते त्या रिपोर्ट वरती बाय युझिंग सॉफ्टवेअर वन कॅन पुट देअर नेम as a developer or as a chemist, as a director, whatever the name आहे ते नेम त्याच्यामध्ये यायला पाहिजे. And most important is the software is registered to the user. म्हणजे ज्या कस्टमर किंवा युजरला जे सॉफ्टवेअर देणार आहे तो त्याच्या नावाने रजिस्टर व्हायला पाहिजे. अँड व्हॅलिड स्पेस पाहिजे. व्हॅलिड स्पेस मीन्स सर्व्हरवरती जो काही डाटा आहे, जो काही सॉफ्टवेअर दिल्यानंतर जो काही 1 वर्ष 2 वर्ष 3 वर्ष जे काही वापरणार आहे सॉफ्टवेअर, त्याचा जो काही डाटा आहे त्या डाटाचा बॅकअप असणं गरजेचं आहे. त्यामुळे व्हॅलिडेटेड स्पेस पाहिजे इन अ सर्व्हर. सो दिस ऑल key points important for the validation of this particular software according to the US FDA 21 CFR norms. So we designed this software according to these norms. When you see the particular slide which shows the login system. त्या लॉगिन सिस्टीम मध्ये एक ऍडमिनिस्ट्रेटर लॉगिन आहे. दॅट ऍडमिनिस्ट्रेटर लॉगिन इज आवर कंपनी. वी फर्स्ट ऑफ ऑल लॉगिन इन टू दॅट सॉफ्टवेअर अँड आफ्टर द लॉगिन वी जनरेट अ युजर नेम. This is called as a Cyclosoft user management. Here we generate username, password of customers or ज्याला दिलंय त्याचा आम्ही username, password generate करतो. ह्याच्यामध्ये आणखी एक फॅसिलिटी आहे ते म्हणजे मल्टिपल युजर्स. इफ कस्टमर्स किंवा समोरची पार्टी जर म्हणते आम्हाला 5 युजर्स टाकायचे, फॉर एक्झाम्पल डिपार्टमेंट वाईज सुटिक्स डिपार्टमेंट, कोग्नोस डिपार्टमेंट, कोलॉजी डिपार्टमेंट, बायोटेक डिपार्टमेंट, या प्रत्येक डिपार्टमेंटचं जर युजर मॅनेजमेंट जर पाहिजे असेल तर वी जनरेट दिस ऑल टाइप ऑफ युजर मॅनेजमेंट युझिंग दिस सिस्टीम. त्याच्यामध्ये 5-6 मल्टिपल अप टू unlimited user you can generate in that particular system. Next is login history. So this is important criteria according to US FDA norms, 21 CFR US FDA norms. हा क्रायटेरिया काय की जेव्हा लॉग इन केलं जातं एका ऍडमिनिस्ट्रेटर थ्रू किंवा ऍडमिनिस्ट्रेटरनं जेव्हा दुसऱ्याला जेव्हा लॉग इन देतो त्याच्यामधून जेव्हा एंटर केलं जातं त्याची हिस्ट्री किंवा त्याचे लॉगबुक असणं गरजेचं आहे. तर त्याचं जे काही ऑथेंटिफिकेशन आहे दॅट ऑथेंटिफिकेशन फीचर्स वी ऍडेड इन टू द सॉफ्टवेअर. सो this is the Cyclosoft is our administrator is admin in that particular date and time. After that he generate a RAM as one of the users. हे जे कस्टमर आहे त्याचं त्या युजरचे एक लॉगिन सिस्टीम करून दिलं होतं. And that software is sell to that RAM, that particular persons, and RAM again log into that software at this time and this date. So ह्याच्यामध्ये तुम्ही बघू शकता की मल्टिपल कधी लॉग इन झाले, मल्टिपल युजर्स कधी लॉग इन झालेत आणि कधी लॉग आउट झालेत. हा जे काही सिस्टीम आहे, हा जे काही हिस्ट्री आहे, हा हिस्ट्री आणि ही सिस्टीम या सॉफ्टवेअर मध्ये तुम्हाला इझिली रेकॉर्ड करता येते किंवा यू कॅन जनरेट द रिपोर्ट बाय युझिंग दिस सॉफ्टवेअर. ओके. नेक्स्ट पॉइंट आहे तो म्हणजे ऑर्गनायझेशन्स. This software provide again one of the new features is called as a Cyclosoft organization management. So whenever the report is generated, that report must be or the report should be on the name of that institute or that particular R&D department. So that's why we added this organization management. याच्यामध्ये जेव्हा कस्टमरला दिलं जातं एक सॉफ्टवेअर त्यावेळेस कस्टमरचा ऑर्गनायझेशन, त्याचा ऍड्रेस आणि त्याचा ओनर नेम जो आहे त्याचा हे सगळे डाटा आम्ही एंट्री करतो. आणि एंट्री केल्यानंतर जो काही रिपोर्ट येणार आहे, whatever the report generated from the software, that report generated on the basis of the data entered into the organization management. So it is a validated software sell to that particular that institute or that R&D departments. Okay, so that's why we developed this particular organization management. Then next point is about the Cyclosoft software and their features. So this particular software shows once you enter into the software, you go to the camera, then select the camera and start the camera. Once you start the camera, you get the live images of a microscopy, which gives the clear cut images of microscopic images. Then you capture the image, then you export the image to the desktop or particularly in your designated particular folders, or you make a folder and you save the images one by one into that particular folders. Okay, this is the first point regarding the camera and capturing. Okay, second point is if you want to record that particular image, so you get the recording by using a particular point is called as a capture recording. Okay, click the capture recording, then you get a recording of that particular images. So recording file जो आहे तो AVI फॉर्मॅट मध्ये असतो. इट प्ले टू ऑल प्लेयर्स. ओके, विंडोजचे जेवढे प्लेयर्स आहेत त्या सगळ्या प्लेयर्स मध्ये ओपन होतो. सो रेकॉर्डिंग जे आहे हे रेकॉर्डिंग 24 आवर पर्यंत रेकॉर्डिंग करता येते. सो वाय वी पुट 24 आवर्स बिकॉज समटाइम किंवा काही सेल लाईनचे स्टडी असतात त्यामध्ये कंटिन्युअस मायक्रोस्कोपीच्या अंडर एक कंटिन्युअस रिॲक्शन ठेवली जाते. म्हणजे सेल्स डिफ्युजन्स, सेल्स डिव्हिजन्स जर ऑब्झर्व करायचं असेल तर ही सेल डिव्हिजन किंवा सेल डिफ्युजन हे 24 आवर्स पर्यंत असतात. त्यामुळे 24 आवर पर्यंत तुम्ही व्हिडिओ रेकॉर्ड करू शकता अँड देन फास्ट प्ले करून तुम्ही ते ऑब्झर्व करू शकता. विदिन द 30 seconds you convert this 1 hour or 2 hours videography to 30 seconds and then fast play करून तुम्ही बघू शकता की सेल्स कशा टाइपचे ते डिव्हिजन झालेले आहेत. ओके, we put recording timeline up to the 24 hours. Secondly, जर समजा एखादा बॅक्टेरियल मोटिलिटी ऑब्झर्व करायचं असेल किंवा एखादा स्पर्म मोटिलिटी जर ऑब्झर्व करायचं असेल तर तुम्ही ते ऑब्झर्व करून त्याच्यावरती रेकॉर्डिंग सुद्धा करू शकता. सॉफ्टवेअर मध्ये रेकॉर्डिंग करून तुम्ही 5 minutes 10 minutes 20 minutes अप टू द 24 hours पर्यंतचे व्हिडिओ रेकॉर्डिंग करून 1 by 1 तुम्ही सेव्ह करू शकता. सो दॅट्स फॅसिलिटी प्रेझेंट इन दॅट in this particular software. Next is particle size analysis. So what is a particle size analysis? So in the market there are two type of particle size analyzer. The first is itself the particle size analyzer is, or it is called as zeta potential. Okay, and second is a microscopic technique, particle size analysis. So microscopic technique एक अशी टेक्निक आहे की याच्यामध्ये पार्टिकल बघायला सुद्धा दिसतात, म्हणजे फोटोग्राफी सुद्धा काढता येते आणि दुसरं म्हणजे त्याचं अनालिसिस पण करता येते. इन झिटा पोटेन्शियल यू गेट ओनली द रिपोर्ट्स अँड द ग्राफ्स, but here you get the photo plus reports plus graph and size distributions and individual cell size, particle cell size and size distribution you get in the report. Okay, so ह्याच्यामध्ये first of all you go to the process of image, then capture the image, then process the image, then go for smoothing of the image or edge sharpening of the image, then you go for analyzer. In analyzer, you have to select the threshold color. When you select the threshold color, it immediately the software capture the dark color colored particles into the windows by using the algorithms and by using a threshold method like different like Hunk's method, like others methods. You have to select the method, then select the threshold color and then the color space and then click for its analyzer for its analysis, and you get this particular report. See here you get the report like the individual cells also and distribution also. Okay, तर याच्या ह्या स्लाइड मध्ये तुम्ही बघू शकता की याच्यामध्ये टोटल काउंट आहे तो एक्झॅक्ट सेल्सचा 81 आहे. एरिया जो काय आहे तो म्हणजे पर्सेंटेज एरिया आहे 25.314 हा एव्हरेज पर्सेंट एरिया आहे आणि एव्हरेज सेल साईज आहे तो म्हणजे 1600 आहे. ओके, सो डिपेंड्स अपॉन फ्रॉम 1 micron टू अप टू द 100 micron पर्यंत तुम्हाला एरिया रेडियस याच्यामध्ये मिळतो. त्याच्यामध्ये साईज डिस्ट्रीब्युशन्स किंवा सेल काउंटिंग, द नंबर ऑफ सेल्स which are present in that particular area, that also you can analyze using this software. आता second important आहे ते म्हणजे calibration. Okay, so before after the capturing of image you can calibrate. First of all, calibrate this image by using the pixel. याच्यामध्ये तुम्हाला एक वरती पिक्सल आहे बघा 800 by 640 pixels. So pixel depends upon different image scale. Okay, जसं तुम्ही कॅप्चर करता वेगवेगळ्या प्रकारची इमेज त्या पद्धतीने त्याचं पिक्सल्स असते. ओके, इथे जर समजा एखादा हिस्टोपॅथॉलॉजिकल सेल्स स्लाइड जर असला असता तर त्याचा पिक्सल वेगळा असतो, पार्टिकल्सचा पिक्सल्स वेगळा असतो. सो व्हॉट एव्हर द पिक्सल जनरेटेड बाय दिस पर्टिक्युलर सॉफ्टवेअर दॅट यू हॅव टू कॅलिब्रेट. ओके, तर तो कॅलिब्रेशन जो आहे तो आम्ही ऑटो कॅलिब्रेशन मध्ये टाकलाय. सो व्हॉट इज ऑटो कॅलिब्रेशन अँड मॅन्युअल कॅलिब्रेशन? सो इन सम सॉफ्टवेअर्स, जे काही मार्केटेड काही सम सॉफ्टवेअर्स आहेत त्याच्यामध्ये कॅलिब्रेशन साठी एक स्लाइड दिलेली असते खाली मायक्रोस्कोप मध्ये. That for that particular slide you have to put first of all into the microscope and calibrate the software and then go for the particle size analysis and all these things. Okay, but आम्ही काय केलंय की पिक्सल्स जे काही येतात ते पिक्सल्स वरनं ऑटोमॅटिकली सॉफ्टवेअर कॅलिब्रेट इंडिव्हिज्युअल व्हॉट जे काही सेल्स आहे त्याचं कॅलिब्रेशन ही इंडिव्हिज्युअल लेवलला सॉफ्टवेअर इटसेल्फ करून घेते. ओके, सो व्हॉट इज द डिफरन्स बिटवीन आवर कॅलिब्रेशन अँड मॅन्युअल कॅलिब्रेशन? जस्ट 5% or 3% व्हेरिएशन्स आहे. म्हणजे त्यांच्या सॉफ्टवेअरमध्ये किंवा मॅन्युअली आपण जर स्लाइड वरती जर लॅबोरेटरीमध्ये केलं आणि ह्या सॉफ्टवेअर थ्रू केलं तर तुम्हाला फक्त प्लस और मायनस 3%, 3% व्हेरिएशन होतो. ओके, सो दॅट्स व्हेरिएशन इज ऍप्लिकेबल इन आवर रिसर्च फील्ड. ओके, नेक्स्ट इम्पॉर्टंट आहे तो म्हणजे काय 3D मॅपिंग. So this is advanced features we are added into software and this is our patented features. Okay, so ह्याचा जो काही अल्गोरिदम आहे तो आम्ही कॉपरेट ऑलरेडी केलेला आहे. तर याच्यामध्ये तुम्ही बघू शकता की जे इंडिव्हिज्युअल सेल्स आहे हे इंडिव्हिज्युअल सेल्सचा डेप्थ किती आहे इन अ 3D मॅपिंग. You can generate the 3D mapping by using this software. You can observe the depth of that particular that particle or particular cells or crystals whatever. त्याच्यामध्ये त्याचा डेप्थ, त्याच्यानंतर त्याचा विड्थ, लेंथ यू कॅन ऑब्झर्व by using this software in a 3D way. Okay, so it is called as a 3D mapping. So you can capture this 3D mapping by using a different plot. You can save the plot or display plot into your research paper also. Okay. So this is the images which is captured from the microscopy, our microscopy. This is the pollen grains. The image, this is the image of pollen grains which is captured from our microscopy. This is also the images of pollen grain. This is the images of the coca-shaped bacteria under the 1000x microscopy. Okay, this is particular slide shows this image, this particular image of the microspores, microspores. Sorry, not spheres, microspores. See here, this is one of the batch of one of the students is as a microsphere. Here, याच्यामध्ये वेगळ्या प्रकारचे मायक्रोस्पियर दिसतात विथ व्हेरिएबल साइजचे. ओके, सो इफ यू वॉन्ट टू मेजर इंडिव्हिज्युअल सेल और इंडिव्हिज्युअल मायक्रोस्पियरचा एरिया रेडियस जर काढायचा असेल तर इट इज ऑल्सो पॉसिबल. जस्ट यू हॅव टू ड्रॉ अ लाईन ऑफ one of the cell or that particular particle and then go into the process and analysis and measure that particular area. So you get the area 69 and angle is minus 64 and you get the radius. Actually the radius मी पुढच्या बाजूला आहे. याचा रेडियस आहे तो अप्रॉक्सिमेटली 50 to 60 मायक्रॉनच्या आसपास याचा रेडियस आहे. ओके, so you can observe individual cells. You can count individual cells manually by using that individual cells counting. Okay. Second slide आहे तो म्हणजे काय inverted phase contrast or particularly dark field microscopy. So he just slide that previous slides is converted into the microscopy. So dark field microscopy चे दोन टाइप्स येतात, म्हणजे ऍक्च्युअली दोन प्रकारे करता येते. एक फर्स्ट म्हणजे काय, एक तर तुम्ही डार्क फील्ड फिल्टर, यू हॅव टू यूज द डार्क फील्ड फिल्टर इनटू द मायक्रोस्कोप. अदरवाइज सॉफ्टवेअर बेस्ड डार्क फील्ड मायक्रोस्कोपी म्हणजे सॉफ्टवेअरचे इमेज प्रोसेसिंग थ्रू तुम्ही डार्क फील्ड करू शकता किंवा फिल्टर घालून. आता फिल्टर घालून जर मायक्रोस्कोपी करायचं असेल तर त्याच्यामध्ये एक ड्रॉबॅक आहे की सोर्स ऑफ लाईट अँड देअर हँडलिंग इज मोस्ट इम्पॉर्टंट. एंड कस्टमर किंवा एंड युजर किंवा रिसर्चरचा एक प्रॉब्लेम काय असतो की मायक्रोस्कोप जेव्हा सेट करता येतो किंवा वापरताना सेट करायचा असतो तो म्हणजे डाऊनवर्ड टू अपवर्ड करायचा असतो, नॉट फ्रॉम अपवर्ड टू डाऊनवर्ड. डाऊनवर्ड म्हणजे काय, इल्युमिनेशन पासून कंडेन्सर नंतर त्याच्यानंतर तो फिल्टर्स नंतर स्टेज नंतर आयपीस नोजपीस आणि नोजपीस नंतर ऑब्जेक्टिव्ह पीस, त्याच्यानंतर मग आयपीस ऍडजस्ट करते कोर्स अँड फाईन. ओके, पण प्रॉब्लेम काय आहे की कधी कधी कस्टमर मधनच ऍडजस्टमेंट करतात फ्रॉम कंडेन्स. त्यामुळे काय होते की डार्क फील्ड हे प्रॉपर मिळेल त्याची गॅरंटी नसते. वन ऑफ द मॅन्युअल प्रॉब्लेम काय आहे की डार्क फील्ड मध्ये जेव्हा तुम्ही ऑब्झर्व करता फिल्टर घालून त्यावेळेस काही पार्ट ब्लॅक मध्ये दिसतो आणि काही पार्ट अगेन इट शोज अ ब्राईट फील्ड. म्हणजे असं स्लाइड मध्ये एका अर्धा अंधार आणि अर्धा असा उजेड दिसतो. पण नो वन कॅन जस्टिफाय वेदर इट इज अ ब्राईट फील्ड मायक्रोस्कोपी or dark field microscopy. So that particular problem we observed every time. So that's why we develop another algorithms or particularly software coding for the dark field microscopy. मग आम्ही एक असा सोर्स कोड डेव्हलप केला की त्याच्यामध्ये डार्क फील्ड मध्ये कन्वर्ट करता येईल. तर हीच इमेज आम्ही काय केली, फक्त डार्क फील्ड मध्ये कन्वर्ट केली. त्याच्यामध्ये अनालाइज अँड कन्वर्ट इनटू द डार्क फील्ड एक बटन आहे, कन्वर्ट टू डार्क फील्ड. Once you click the convert into dark field microscopy, then you get this type of images. ओके, याच्यामध्ये हे मायक्रोस्पियर मध्ये तुम्ही बघू शकता, सॉरी मायक्रोस्पोर्स मध्ये आपण मायक्रोस्पोर म्हणजे काय म्हणतो की असा एक स्पियर आहे की त्याच्यामध्ये छोटे छोटे स्पोर्स आहेत, त्याला म्हणतात मायक्रोस्पोर्स. गोल जे मायक्रोस्पियर आहे याच्यामध्ये पण छोटे स्पोर्स आहेत. ते यू कॅन कन्फर्म दिस इज द मायक्रोस्पोर बाय युजिंग दिस डार्क फील्ड मायक्रोस्कोपी. ओके, म्हणजे एससीएम आणि इलेक्ट्रॉन मायक्रोस्कोपीला जायच्या अगोदर तुम्ही कन्फर्म करू शकता की आमच्या आवर फॉर्म्युलेशन कंटेन द मायक्रोस्पियर, एक्झॅक्ट मायक्रोस्पियर, मायक्रोस्पोर्स वॉट एव्हर. ओके, सेकंडली यू कॅन ऑब्झर्व द डिफरंट एजेस. त्यामुळे शेप आणि एखाद्या पार्टिकलचा शेप बघायचा असतो किंवा त्याचा ऑर्नामेंटल स्ट्रक्चर्स, इफ यू वॉन्ट टू फाइंड आउट द ऑर्नामेंटल स्ट्रक्चर्स. So that ornamental structures one can find easily by using this dark field. Here the cell is converted into glowing cells and the background is converted into the dark. Hence it is called as a dark field. याच्यामध्ये तुम्ही बघू शकता की प्रिव्हियस स्लाइड्स मध्ये जे छोटे पार्टिकल्स जे कळत न कळत दिसतात, इकडे उजव्या साईडला खालच्या बाजूला तुम्ही बघू शकता की असे काही छोटे पार्टिकल्स आहेत की ज्याचा साईज 1 मायक्रॉनच्या आसपास आहे. जे मायक्रोस्पोर्स आहेत ते तुम्हाला इझिली इथं कळणार नाहीत, पण ते डार्क फील्ड मध्ये इझिली कळतात याच्यामध्ये. ओके, सो हे त्याचा ऍडव्हान्टेजेस आहे या पर्टिक्युलर या सोर्स कोडचा. ओके, नेक्स्ट पॉइंट इज दिस इज द इंडिव्हिज्युअल cells measuring. So you go to the analyze and first of all select the individual cells, go to the analyze and click on the measure. You get the individual cells with their area, radius, angle and perimeter. Okay, so last point of our slide is about the documentation system. So our software shows the different documentation system like report generations. Okay, in report generation at the end of the analysis it is possible to export the image. You can save the image and export the image and you can measure the individual cells or particular individual images, the results either on Excel sheet or on report generated in a MS Word. So आमच्या सॉफ्टवेअर मध्ये जे काही रिपोर्ट्स येतात, that reports you have to export into the Excel with respect to different graphs, plots, whatever जे काय असतील ते सॉफ्टवेअर मधून जे येतात ते, प्लस काय असतील you get in a MS Word. So it is easy to transfer all this data into your research paper. Okay, the next is a template is freely configurable and can be modified according to laboratory standards. Okay, so एक बाजूला एक उजव्या बाजूला एक मी रिपोर्ट दिलेला आहे, which is called as a cell count. So you get the report of individual cells according to this particular report. In this report you see एक तर cells आहेत 1 2 3 4 5 6 whatever the cells जे काही मेजर झाले त्याचा एरिया इन मायक्रोमीटर आहे आणि रेडियस इन मायक्रोमीटर आहे आणि त्याच्या बाजूला जे काय ते सेल डिस्ट्रीब्युशन्स आहे. म्हणजे 1 to 10 मध्ये किती सेल्स आहेत, 10 to 20 मध्ये किती आहेत, 20 to 30 मध्ये किती आहेत आणि असं अप टू 100 मायक्रॉन पर्यंतचे सेल्स किती आहेत त्याचं डिस्ट्रीब्युशन. यू गेट द डिस्ट्रीब्युशन्स अँड बाय युझिंग दिस डाटा our software generate a distribution graph. Actually, I am not given here, but it generate the distribution graph, and that distribution graph you have to export into the your Excel. Okay, so all over the software मध्ये मी मगाशी म्हटल्याप्रमाणे 3% व्हेरिएशन आहे. 3% व्हेरिएशन मीन्स दॅट इज 3% व्हेरिएशन इज अ स्टँडर्ड व्हेरिएशन. जेव्हा मॅन्युअली तुम्ही करणार आहे आणि आमचा रिझल्ट आहे त्याच्यामध्ये फक्त 1-2% फक्त डिफरन्स पडतो. दिस इज अ व्हेरिएशन because this is the artificial intelligence based software and our आणि आपण जे करतो लॅबोरेटरी मध्ये ते मॅन्युअल मेथड असतो. ओके, त्यामुळे थोडाफार व्हेरिएशन येण्याचे चान्सेस असतात. That's all are applicable. Okay, so this is all about the our microscopy. Okay, sir. Hello.
Yes, sir. Yes, sir. You are audible.
Yes, sir. I'm
Yes, sir.
completed my
Okay.
slides.
Okay.
In brief, actually, I will complete it.
Okay, sir. No
Okay,
problem.
sir. You have explained very nicely.
काय क्वेश्चन्स असतील तर मला सांगा. ऍक्च्युली कसं आहे सर, त्याला एक लॅबोरेटरी डेमॉन्स्ट्रेशन पाहिजे. हे कसं आहे स्लाइड न एवढा हे होणार आहे, पण आपण कधीतरी अरेंज करूया लॅबोरेटरी डेमॉन्स्ट्रेशन.
So the session is now open for the discussion. If you are having any questions, please ask. Okay, I think there are no questions.
ओके ठीक आहे.
Okay, so Sachin sir has explained very nicely about types of various microscopy, and in fact he has shown how it works and uses, and he has explained very nicely about digital microscopy, its applications. He also told about software systems and images. So I am very thankful to Sachin sir for such informative lecture, and I request session coordinator Dr. Sarde sir, training coordinator Dr. Sarde sir to present Sachin sir with a certificate of appreciation.
Sir, please accept this certificate of appreciation from our side. We will mail you the soft copy of this certificate.
ओके
Sachin,
सर. ओके हा ओके सर.
Sparing a time.
ओके सर.
Okay, now with Sarde sir's permissions, shall we end the session, sir?
Yeah, today's session we can end.
Okay, thank you, sir. Thank you, everyone. So tomorrow, as per the schedule, the sessions will be conducted. Please be ready sharp at 10 a.m.
Yes, thank you very much, participants. Tomorrow we will meet at 10:30 sharp. Again, we will have the 4 lectures tomorrow. So again, the lectures are from the 2 are from the industry and 2 are from the academics. So I request everyone to join at sharp time so that we can conduct all the 4 lectures within time. So now we can leave the meeting. Thank you very much for today. At evening, you will get the feedback form. So please fill that feedback form for all today's lecture. Thank you. Thank you, Pandey sir.
Thank you, sir. Thank you. Thank you, Rahul sir.
Sachin sir, thank you very much.